Have you ever been checking out on your favorite shopping app? You hit the buy button and the screen just freezes, then it crashes? That real-world nightmare, a broken app or a failed payment, is exactly why API testing is absolutely critical. So by the end of this explainer, you're going to understand APIs from the ground up. We're talking manual testing with Postman, writing fully automated tests, and even running some basic security checks.
Think about that payment failure for a second. Behind the scenes of almost every single app you use every day, there's an API quietly trying to do its job. It's the invisible bridge making things happen, and when it breaks, the entire business grinds to a halt. Today, we are going to make sure you know exactly how to prevent that from happening.
Here's our roadmap for today. We'll start with the core concepts, make our very first request, write some automated tests, look at variables, dive deep into debugging with the Postman console, and wrap up with some essential security checks.
Let's kick things off with Section 1, Core Concepts.
So what exactly is an API? Well, the easiest way to picture it is by thinking of your favorite restaurant. You are the customer, right? In tech terms, you're the client. You're sitting there looking at a menu. The kitchen is the server, where your food, or in our case, the data, is actually prepared. Now, you don't just walk right into the kitchen and grab your food. You need someone to take your order to the kitchen. That's the API. It acts like the waiter taking your specific request to the server and bringing the correct data right back to your table.
To interact with that data, we use specific HTTP methods. Think of a GET request like just looking at the menu. You're only fetching data. Post is when you're placing a brand new order, sending data to create something entirely new. Put is like modifying your order if you change your mind. And delete, well, that's simply canceling your order entirely to remove the data.
Now, when the waiter comes back, they give you a status. These numbers are basically the universal language of API testing. They tell you exactly if your request succeeded or failed. Anything starting with a 2, like a 200 OK or 201 created, means awesome, success. A 400 level error like 400 bad request, or the famous 404 not found, means that you, the client, made a mistake in the request. And a 500? That means the server, or the kitchen, is having a major meltdown.
Moving right along to Section 2, Making Your First Request.
It's time to get our hands dirty. We're going to make our very first manual request using Postman, an incredibly popular testing tool. We'll use a public API, like the Simple Books API. If we do a basic GET request to fetch books, it throws a massive list at us. But what if we want something specific? That's where query parameters come in. They help us ask the server for very specific slices of data. By just adding a question mark and type equals fiction to the end of our URL, we tell the API to filter the results and only bring back the fiction books.
Now, while a GET request just asks for info and doesn't really need any extra payload, a POST request is different. You're actually creating data, which means we have to carefully format our payload in JSON. JSON is really just a simple way of formatting text into key value pairs so the server can easily read it. If you're submitting a new book order via POST, your JSON body has to perfectly spell out the details, like the specific book ID and your customer name.
All right, Section 3, Writing Automated API Tests.
Checking everything with our own eyes every single time? Yeah, that gets exhausting fast, and it's super prone to human error. Imagine having to run 100 requests and manually staring at the screen to verify if each one says 200 OK. No way. That's not scalable. Automation means we let Postman do the heavy lifting, and we only step in if our written test assertions throw an error. Instead of using our eyes, we use Postman's built-in Tests tab to write tiny snippets of code that verify the response automatically.
Here's what that looks like in the Tests tab. You'll use functions like pm.test to name your test, and then an assertion like pm.response.toHaveStatus200. We can even parse the JSON response into a JavaScript object. Once we do that, we use pm.expect to verify some incredibly specific things. For example, we can write 3 simple, super useful tests right now. One to ensure the status code is exactly 200, another to guarantee the response time is under 300 milliseconds, and a third to check that an ID property actually exists in the response body.
Section 4, Variables and Data-Driven Testing.
Okay, so we need to stop manually copy-pasting data from one request to another. Hard-coding a URL in 50 different requests is honestly a disaster waiting to happen if that server address ever changes. By wrapping our base URL or specific order IDs in double curly braces, we create global and environment variables. This dynamic approach makes our test suite incredibly powerful and adaptable. You change the variable value once, and boom, it updates instantly across your entire collection.
This is a total game changer for real-world projects. And it gets even better when we start feeding different data from CSV or JSON files to run data-driven tests at scale. Instead of testing the customer name John over and over, you can use a variable to test 100 unique names from a file completely automatically, without lifting a single finger.
Section 5. Debugging with Postman console. Debugging is an absolutely critical skill for any tester. But what happens when our automated test fails and we get a glaring red error on the screen? Well, when you get an unexpected failure, the Postman console is your magnifying glass. It's a slightly hidden diagnostic tool right at the bottom of the screen that records the exact raw details of every single request going out and every response coming back. When a test fails or a status code throws an error, you really must learn to read these response logs. It is absolutely vital for diagnosing what went wrong.
Let's look at a practical example. Say you send a post request to order a book, and you get a 400 bad request. The API is basically telling you, hey, you formatted something wrong. If we deliberately leave out a comma in our JSON body, the API rejects it. By opening the console logs, we can literally see the exact raw text we sent to the server. We can look closely at the response logs, and it will point out exactly where we messed up the syntax.
So whenever you find yourself stuck, just follow this simple recovery process. Step 1, note the failure. Step 2, open up that Postman console. Step 3, expand the specific request body and response logs. And Step 4, hunt down the missing data or typo. Practicing this exact workflow makes you a troubleshooting detective, and it ensures you are truly job-ready when facing real broken APIs in the wild. Section 6, security checks and next steps.
For our final major section, we're going to lock down our APIs and look at how to safely handle sensitive data. If you try to create an order on a secure API without registering as a client first, you are going to get a 401 unauthorized error. Why? Because you're missing a crucial security checkpoint. The server has no idea who you are, or if you even have permission to create data. This actually touches on some of the top API security risks out there, like broken object-level authorization.
To fix those authorization errors, we typically register our client to get an access token, often called a bearer token. Think of it like a temporary VIP pass. We then inject this token into the authorization header of our request in Postman. But listen closely to this part. You must always use secure HTTPS connections and always hide these secret tokens in your variable's current values, not the initial values. Never, ever expose your private keys publicly.
Okay, let's do a rapid 10-second recap to summarize our learning path. APIs connect clients to servers. We use get, post, put, and delete to manage data. We use pm.test to automate our visual checks. Variables completely eliminate manual copy-pasting. The Postman console is your ultimate tool to diagnose failing logs. And lastly, once your tests are built, you can run your entire collection automatically using a command line tool like Newman or GitHub Actions in your continuous integration pipelines.
Which brings me to your final challenge. Grab the API cheat sheet from the resources, dive into Postman, and let's see if you can test the Simple Books Orders endpoint using all 4 different HTTP methods. See if you can get those status codes to read 200 and 201 and share your results. You now have the foundational skills to conquer the API testing landscape. Keep exploring, keep practicing, and I'll see you next time.